Today we are seeing about the satellite communication. So satellite communication is an important role in recent trend because we are having the planets around the sun. Earth is the third orbit around the sun. Okay, so here this is the orbit. Orbits. What's the orbit? Orbit means nothing but the sun is center of the orbit and the Earth, Mars, Jupiter are cyclic around the sun as an elliptic orbit. So this is a sun family. This family it consists of planets. It's around the sun in elliptical manner. Okay. Motion of Mars on the sky. So we are seeing about the position of Mars against star background 1971. So this is the star background in 1971. So Earth-centered model. So Earth-centered model, nothing but the Earth is in the center and the satellite is around the Earth axis parallel to the Earth, and the satellite axis also parallel to the Earth axis. Introducing the idea of epicycle to explain the motion of planet. So next one is sun-centered model. So what is the sun-centered model means nothing but in the top view we can see the top view. You can see the top view of Earth and Mars orbit. So here in Earth orbit, they are given an angle. The suggestion that would be simple to have the planet orbit the sun. We cannot occupy a special place in universal. So here this is the points that connects Earth orbit and Mars orbit and towards the north. So one is a Leo. So these are the things. These are the things is sun-centered model, because sun is centered and around the sun the Earth and Mars are arbitrated in ellipse manner. So the coinciding line of Earth equator and Mars through the North Pole. So this is called Earth-centered model. Kepler's law of planetary motion. Using a precision measurement of position of planet in the sky collected by Jonix, Kepler detect three laws of planet motion. Three laws. Kepler says the three laws. So one is the orbits are ellipse. So the orbits are in ellipse shape. So next one is planet move faster when closer to the sun. And slower when further away from the sun. So sun is center, around the sun the Earth is orbited in ellipse manner. So another one is the Earth sails around the sun, and satellites are orbited around the Earth. So this is closer to, so the planet is closer to Earth means it is round a fast manner, but in further away from the sun it goes too slow, because the Earth is closer to sun means, so it takes 1 year that is 365 days to round a orbit around the sun. But in same time, for example, Mars is away from the sun. So it goes slower because it takes 500 days to complete a round. Another one is planet further from sun to large to orbit. So I already told that example, Earth is around 360 days for one rotation around the sun. So the Mars having 500 days to complete a one round of orbit. So this is an elliptical one. Orbits or ellipse. So we know that ellipse. So ellipse is an ellipse having semi-major axis, two semi-major axes and two focus, one major axis. These are the content in the ellipse. So the ellipse E is equal to 0. So the point acts as a circle. E is equal to 0.5. E is equal to 0.5. The foci is 1 and 2 in the distance of some distance, that is 0.5 E. So there is two foci. Okay. So it is an elliptical one. Another one is 0.9. So 0.9 it goes along the distance. So it is an exact elliptical shape. Another one is E is equal to 0.99. So E is equal to 0.99 is a smaller ellipse. So when we increase the value of E, the elliptical orbit is formed. So planet move faster when closer to the sun. So here this is an elliptical manner. When the planet is closer to the sun, it goes along the faster orbit with the sun. That is our Earth planet having elliptical shape. So the planet further away from the sun take longer to orbit. So here they are given as Mercury, Venus, Earth, Mars, Jupiter, Saturn. So these are the planets. Some planets around the sun. So it depends upon the semi-major axis and sliding period. So these are in years. So depend upon the years. So 2 years, 3 years, 1 year is having 365 days. So this graph is belong to semi-major axis and slider period. So another one is Gluli proved the planet orbit the sun by observing Venus. So depending upon the alpha, we can detect the things. Observing the Venus. So we are observing the Venus planet. The alpha is equal to 58. The angle is 58. Alpha is 42. Alpha is 24. Alpha is 15. Alpha is 10. So this reduces the size of Venus. So next one is Earth-centered model. So Earth-centered model means nothing but the Earth. So in between Earth and Sun. So Earth is orbited ellipse manner to around the Sun. So here the concept is center of Venus is never seen very far away from the Sun. So Venus is nearer to the Sun and Earth is far away from the Sun. So this is Venus having epicycle of Venus. So we are comparing that the same line Earth, Venus and another one is Sun. So that Venus having the epicycle of Venus. Epicycle of Venus is around ABCD. So next one is, another one is the planetary model. Venus and Sun must move towards with the epicycle of Venus centered on the line between Earth and Sun. So this is an elliptical cycle of Venus. Elliptical cycle of Venus. So Sun is directly from the Sun we are directly project a line through the Venus and to the Earth. So this is the model. Then Venus can never to be opposite side of Sun from the Earth. So it can never be phases. So this is a phase that along Venus, Earth and Sun are coming same line. This is called Earth-centered model. So Venus is closer to the Sun, but Earth is far away from the Sun. Sun-centered model. So this is a sun-centered model. So here the first one is Sun, another one is Venus, another one is Earth. So here the Venus circle around the Sun and Earth also circle around the Sun. So here the alpha, we see the alpha number is 58, means it is viewed as bigger. Another one is alpha is 42, alpha is 24, it is going decreased. So alpha is 10. Okay, so here, so depend upon the alpha value, the visibility of Venus is decreased. The sun-centered model, Venus can show all the phase. Another next one is Isaac Newton. Newton realized that the same physical law which applied on Earth also applied to the Sun, Moon and planet. He formulated laws that describe the motion of object both of Earth and space. He formulated the laws motion of object both the Earth and space. So depend upon the space, the Earth rotation is increased or decreased. So next one is Newton's law. The law of inertia. One is law of inertia. A body remaining at rest or moving in a straight line at the constant speed unless acted upon by outer side force. So we are it is going on straight line. When the obstacle hits this planet or a stone, so unless there is any force applied, it going on through the straight line. That is Newton's law, first law. The force on object is directly proportional to the mass and acceleration. So here one stone is going on a straight line when the another force hitting that one. So depend upon the external force, mass and acceleration. So the mass of when two cars are collide, so that the car depend upon the mass and its acceleration. When it hit another car, so that accelerate. So in the accident, in the car accident, they are using accelerometer, because accelerate when two cars are collide with each other, the acceleration is increased. So depend upon the acceleration and mass hitting body, the collision level is raised or decreased. The principle of action and reaction, whenever one body exerts a force on second body, the second body exerts an equal opposite force for first body. I already told that. For example, one car is going along the road, one car is coming from another road, hitting these two, the collision is taking place. So acceleration and mass are the main constraints in the collision of cars, everything. So next one is Newton's law of gravitation. So the gravitational force exists by a body is proportional to its mass. Gravitational force exists by a body is proportional to the mass. Okay, gravitational force. What is the gravitational force? When we throw a stone to higher, but it reaches the ground. So the gravity force from ground itself, it goes to the ground. But in space, we are throwing a stone, means it goes upwards, but doesn't return to the ground because the gravitational force is exactly zero. So the gravitational force extended by an object decreased with square of the distance. If a person B is twice far away from the sun, so far away from the sun as person A, then the force of gravity on person B is only 1/4 of the person. So we consider A as the earth and B as a mass. So A is closer to the sun, but for gravitation force, the earth is mass is behind the earth. So the gravitational force, when we move a planet from closer to sun, further away from the sun, so the gravitational force also decreases. So person A is earth, means person B is mass. So depend upon the, for example, so we are calculating gravitation force as 100 earth, sun to earth, but for mass further away from the earth, so the gravitational force is decreased by 1/4. So the 25 is the value of person 2. Newton's law explained Kepler's law. So here we already seen this diagram. So in the diagram, Mercury, Venus, Earth, Mars, Jupiter, this coming to away from the Earth. So it slightly with the Earth year also. So depend upon the distance from Sun. So the period of year also extended for various Jupiter, Saturn. So here Newton's law explained Kepler's law. So here to make a ball move at your high speed in small circle with struggle pull. To make same ball at lower speed at larger circle using a weak pull. So to make a planet move at the high speed in a small orbit requires strength gravitational force to make the same planet moves at the slower speed in larger orbit. Larger orbit requires only a weak gravitational force. So I already told that when the planet is moving from the sun is greater or far away from the sun, the gravitational force is decreased. So in this law, so next one is planet move faster when closer to the sun. We already discussed this one. When the circle, the orbit is elliptical orbit, so that one time the earth is closer to the sun, so it can fastly move in the orbit. So next one is mutual orbit of planet and star. So planet also, so star also circle around the sun in elliptical manner. Center of mass. The center of mass is the sun, and next one is star. Next one is planets. So here the stars are having its own light, but the stars are thousands or lakhs of kilometers away from the earth. So it looks small, but we doesn't reach, even the earth doesn't reach the star, because the star is away from our planet, that is lakhs of kilometers, and it having a fire, blooming fire. So another one is the sun also having a blooming fire. Anyone doesn't go to nearer to the sun, because it is a huge fire like. So next one is astronomical unit. So astronomical unit means nothing but the given diagram is nothing but the center is sun, and around the sun the earth is rotation. So the half of the annual ellipse circle line of sight in January. This is the part of in January. Earth reaches this path. Another one is another half is light of sight, that is to July. So June and July. January it reaches here, and July it reaches off of the semi major axis. So at the January, line of sight to the star. So line of sight to the star. Another one is line of sight to the star in July. So this is we are drawing, and from the star we are drawing a parallel perpendicular line to sun. So the angle is parallax angle. So the totally the astronomical unit, one or two astronomical units are there, from the sun to the January distance, and sun to July distance. These are the astronomical distance from the earth to sun. So this is a calculated as astronomical unit. D is equal to 1 by P. P is the parallaxis in arc second. Distance to star is parasecond. So parasecond is represented as 3.26 light years. So next one is stalling parallax. Here the same concept. So first one is sun. The sun is rotated, circled by our earth. The earth reach here January and here July. So this is an elliptical manner. We already know that one astronomical unit is earth to sun distance. Okay. So we are given this a sign of light from January and July to the star, and it is extended to the limit. So extend to the limit, it having a circle Beyond the star, we are having the circle. These are the imaginary lines only. So the P is the parallel axis, D is the distance from sun to star. So this is the equation. As the Earth moves away from the one side of sun to other side, a nearby star will seems to change its position related to distance background star. Okay, D is equal to 1 by P. Distance to nearby star. Okay, distance nearby star. When the star is nearer to sun, so next one is parallel axis angle of the star in arc second. So we are creating a background along the star. After hitting the line side of star that is extended, that is an elliptical one. So next one is the same concept. The star is nearer to the sun means, so we can having a small axis length. There is background of star is a small one. So when the star is closer to the sun means, the line of sight from January and July are intersected, and at the background of that one we got a larger ellipse. Using the parallel axis to determine distance, the bright star Virgo has your measured parallel axis of 0.1. P is equal to 0.1. This means that Venus move from 0.1 to minus 0.1 with respect to distance of star over a year observation. So D is equal to, in terms of PC, 1 by P is equal to 1 by 0.1 is equal to 10 PC. Okay, this is 10 PC from Earth. So size of astronomical object. How can we measure the size of astronomical objects? The same way, the measurement using triangles. The small angle formula. The small angle formula is D is equal to theta D divided by 60/65. So D is the linear size of object. So D is the linear size of object. So we are considered this is an Earth. So the Earth diameter is measured. So angle theta is the angle size of object. Angle subject of object. D is the distance of object. D is the distance of object from the eye to Earth. So in between the eye to Earth, we are having Venus. So this is the Venus. So here we are seeing the line of sight through the Venus to the Earth. This is the Earth and this is the Venus. So here the angle size alpha is the angle I to the Earth. So this is the angle. For example, 45-degree angle. So next one is distance D. Distance is the eye contact to the Earth. So here we are crossing the Venus and we are seeing the Earth. So Venus block the Earth sight. So next we are consider B. So the Earth is another one. So we are consider this is on Mars. So Mars is less than Venus diameter. So we doesn't see, but imaginarily we can draw the lines. So next the C diagram, it shows the linear size of Earth diameter and angular size of alpha and the distance that ice to Earth. Ice to Earth. So here on November 28, 2000, 2000, the planet Jupiter 609 millions kilometer from Earth and had angular diameter of 48.6. During the small angle formula to determine the Jupiter actual diameter. So we are going to measure the Jupiter diameter. So here d is equal to angle phi, angle theta into d divided by 20, 62, 55. So the small angle formula. So these are the d is equal to linear size of object, angle size of object, distance of the object. So put the values in the equation. We can get 143,000 kilometers. So we are calculating the diameter of Jupiter. So this is a small problem. If we spin a top, it's very hard to spin exactly in straight. Usually it obeys around the circle. The spinning earth obeys in exactly the same. This is called precision. So here this is the precision of earth. So earth is not as a perpendicular axis. So it is tilted to some angle. Earth rotation angle now. So the rotation angle is some polarized one. Okay. So there is some angle in between perpendicular with earth axis. So next one is earth rotation axis is approximately AD 14,000. So there are two ways. Polaris is tilted to right and towards various means tilted to left. So this is the earth orbit. So this is the earth orbit. It is pinned by angle. That is not a perpendicular one. This is having angle. Okay, next one is launching procedure. So launching procedure is so here we consider rocket. In the rocket they are fitting a satellite. They are loading a satellite, and the rocket is fired towards the orbit. So this is the Earth, this is the orbit. So this is the final orbit. It is like ellipse. So this orbit. So the rocket is take towards the perpendicular to the axis, but afterwards it circulates and go high and it sets to the orbit. Okay, the orbit is transfer orbit. So here there are two types of satellite orbits are there. Low Earth orbit satellite are directly injected into orbit. This cannot be done in geostationary. So here the low Earth orbit means nothing but here the Earth is here. Around the Earth the satellite is small difference in distance from Earth to satellite. So the satellite around the Earth is an elliptical one. So here this is low Earth orbit, another one is geostationary orbit. In the geostationary orbit, the position is 36,000 kilometers above the Earth's surface. That is called geostation orbit. So landing system. So landing system is launching vehicles are there. So here. So next one is off-man transfer orbit. The German civil engineer Walter Hoffman who first proposed it. The transfer orbit is selected to minimize the energy required for transfer. This orbit forms a tangential to low latitude orbits at the part of perigee and tangential to higher latitude of orbit at the point of a bridge. So here, so 2 is tangential. This one tangential to perigee. This one is a bridge. So here 2 tangential lines are here. Next one is launching vehicle and propulsion. The rocket inject the satellite with the record thrust into the transfer orbit. With the STS, the satellite carries a perigee. Satellite carrying a perigee motor which impactly the record thrust to inject the satellite into transfer orbit. Similarly, upkick kick motor is used to inject the satellite in the designated orbit. Generally, it takes 2 months to 1 or 2 months to launch a satellite and full function. So we are launching a satellite, we are placing a rocket, and in the rocket the topmost of part is a satellite, and we are fired, and it launches into transfer orbit. The Earth station forms telemetry, tracking and commands to control the satellite transmitter and facility. Thrust is your reaction force described by Newton's second law and third law. So here telemetric tracking. What is the tracking? So when we give an aircraft in the aircraft we are having satellite. So it is launched. So it takes 1 month to launch the satellite. So we are tracking along the rocket and the speed, and another one is direction to set the orbit. Another one is tracking. So tracking means the rocket is tracked by the sensors, the connecting sensors, and we are tracking the rocket to a constant orbit, to set a constant orbit. So another one is command function. So command function also we can command from ground station to the satellite. So satellite can capture the images in any angles with this for taking photo along the planet. We can take the research along the planet. For recently they are taking in Mars. Another one is Mars, Jupiter. We can analyze that one. So here the recent Indian research organization is also sent a satellite to the moon, and another one is the Chandrayaan 3 is landed in the moon safely on south pole, and it takes the photograph and sent to the Earth. But the failure is only the Chandrayaan 2 is landed on Earth, moon, but Another one, vehicle is so the open the instrument and the vehicle should be come out of there and it goes to research the moon automation. The automation car is safe, but the unfortunately the weather is -24 for 14 days. The Chandrayaan 3 in the moon is fully destructed to use. So they have tried to rehabilitate that one, but does it work? So the 80% of research Chandrayaan is achieved, but 20% is a failure. So the research are going on in the Mars also. The NASA take the research on Mars, whether the man can live in Mars. Okay, in recent one. So kicking motor refers to rocket motor regularly employed an artificial satellite designated for geostationary orbit. So here the motor is kick motor. Kick motor referred to rocket motor. So rocket motor regulator employ a artificial satellite designed for geostationary orbit. As the vast majority of geostationary satellite launch or carried out from the spaceport at significant distance away from the Earth equator. So the two types I already told that low Earth orbit, another one is LEO, another one is geostationary. So geostationary is away from the sun, and the lower Earth orbit is closer to the Earth. Next one is transfer orbit. It is better to launch rocket closer to the equator because the Earth rotates at a great speed than their poles. This extra speed at the equator means a rocket needs less thrust and less fuel to launch into orbit. In addition to launch into the equator, providing additional 1,336 mph of the speed, miles per hour of the speed, one of the vehicle reaches orbit. This speed bonus means the vehicle need less fuel and feed space can be used carried more payload. Payload means nothing but we are providing services from satellite. So here we are launching a satellite. So that is for a research of telecommunication means we get the payload is a telecommunication service. So for other purpose, the DTH channels extract from the satellite means that is also an application of satellite. So we are having the satellite DTH, that is Sun DTH, Tata Skies DTH, Airtel DTH. These are some payload applications for a satellite. So often transfer orbit. So transfer orbit, I already told that two orbits are there. LEO, that is lower Earth orbit. Another one is higher Earth orbits. So this is lower Earth orbits. So this is a smaller orbit. Another one is higher Earth orbits. So launching stage of GEO. So GEO means geostationary orbit. So here in center of the Earth, so we are launching here. We are launching a spacecraft. It carries the satellite and it moves along the vertical to the earth, and after going some distance, it rounds orbit and it reaches the geostationary orbit once. And the Earth, the center of Earth, and there are two possibilities are there. One is around the Earth the satellite can around the Earth satellite can orbit. Another one is in the same Earth orbit. So the center is Sun, and satellite also in the same orbit to the Earth. Okay, so same orbit to the Earth. This is the orbit of Sun, orbit of the Earth. This is the orbit of the Earth. So the same motion, same orbit, the satellite also launched and it rotates the thing. Rocket launching. Your rocket launching is a cut-off phase of flight of your rocket, launching from orbital space flight or launching into a planetary space, or usually from a fixed location on the ground, but may also be a floating flat, or potentially a super heavy class airplane. So next one is launches of suborbitally flights. So including missile launcher. Another one is mobile launcher vehicle. Yeah. Submarines means nothing but in the under the sea, that is called submarine. So submarine also having a launcher, some missiles to fight with other countries. So here, so these are something air launching from a planet. From a planet we can, this one, a surface ship. Another one is an inclination real. Rockets lead launching. So the rocket launching techniques generally refer to entire set of system need to successfully launch vehicle, not just vehicle itself, but also firing control and control system, ground control system, pad and tracking station need for successful launch or recovery. So here we have to track the station. When we are launching a rocket, in the satellites are there. So when we launch the satellite, so we have to track the stations with the sensors in and around the satellite, and which speed is going, what are the height the launcher is here. Orbitational launcher vehicle can take off vertical and begin progress land over. So I already told that the launching is in takeoff in vertical, but it goes to the around the breach and tangential to the breach. Another one is a breach also having tangent. So afterwards only it going to launch the satellite. So satellite, the launching of satellite is and full function is about 1 to 2 months, because we are launching thousands of kilometers from the earth. So next, so this is another launching model. So here spacecraft. So spacecraft having some elements. So that is one motor. So many elements are there. So the aperture motor firing, aperture kick motor. So these are the some motors. Another one is radio frequency, pre-jig kick stage, action control system, space transfer system. So these are the some critical position along the parameters that refer to the satellite. So satellite orbits. The satellites are specifically made of the purpose of telecommunication. So they are used for mobile applications such as communication to ship. So mobile application, communication to ship, vehicle. So planner, hand holding terminal, TV, radio broadcasting. So there are so many applications for satellites. So one is communication to ship, mobile communication. Another one is vehicle. So another one is planes, aeroplane. So TV. Another one is radio broadcasting. Yeah, a satellite works more efficiently when transmission of a satellite works more efficiently when the transmitter are focused with decided area. When the area is focused. Okay. So we have to launch in the correct orbit, because there are two orbits are there. One is the satellite around the earth. The satellite circles around the earth in elliptical form. So there is one. Another one form is satellite is parallel with which one? Earth axis. Earth is surrounding the sun. So the same orbit, the satellite also moving along the earth. So these are the things, orbits. Satellite and the law pattern play a role and must be designed so to best coverage the designator, geographical area, weather forecasting, radio and TV broadcasting, military and satellite, navigation satellite, global telecom connection, remote area, global mobile communication. So these are the applications and used for the satellite. So they are launching the satellite for forecasting, radio and TV broadcasting, military and satellite, navigational satellite, global communication satellite. Another one is global mobile communication. So this is the parameters in the satellite orbits. So average height HA, another is pitch height HP and illumination angle. So these are the some concept regarding the parameters. So another parameters are there. So I already told that the earth is in spherical shape and there are two. This is the equalator. The equalator is a center round. So the center of earth axis. We are drawing a circle around the center of earth, means that is called equalator. So in equalator, retrograde orbit, another one is post retrograde orbit. So this is angle towards the left hand side, and this is on right hand side. So these are the prograde and retrograde orbits. So these are the orbits, and the Earth having the south pole at down and another one is north pole. So equator is nothing but the center of the Earth is, we are drawing a circle along the center of the Earth is called equator. So in equator there are some countries are there. The countries of Antarctica. So Antarctica there is no living beings, but only snow blocks are there. So another one is a bridge. A point for satellite far away from the Earth, that is called a bridge. So bridge, a point of satellite closer to the Earth. We already discussed in the previous diagram. This is the bridge and this is the bridge. So here these are the parameters, some of the parameters. So next one is orbitational permutation. In reality, other forces also play a major role and affect the motion of satellite. The orbitational permutation means nothing but other factor that affects the motion of satellite. So what are the factors? We are going to discuss about that. Those factors are gravitational force of sun and moon along the atmospheric drag. The effect of sun and moon are pre-known that of geostationary Earth satellite, where the atmospheric drag effect is more pre-known for low Earth orbit satellite. So low Earth orbit satellite means, so it is closer to the Earth, it surrounds the Earth. As the next one is effect of a non-cylindrical, non-spherical Earth. As the shape of Earth is not perfect sphere, it causes some variance in the path followed by satellite along the primary. It is first result for oblate Earth act on the satellite produce a change of orbital parameter. So the uncertain condition that non-spherical Earth, so it forms some problem in the motion of the satellite. It affects the motion of satellite when the Earth is non-spherical shape. So it changes the parameter of satellites, orbital parameter of satellites. This causes the satellite to drift as a result of regression on nodes and latitude of the point PG. Latitude as the orbit itself move respect to Earth. The resultant change is seen value of PG and right assignment node. Assignment node means nothing but the node is nothing but south to north. This is the south and this is the north. The elliptically it rounds. So here this is called ascending node. Another one is descending node. That from north to south. That is called. These two are the things. Okay. Next one is atmospheric drag. Atmospheric drag means a low Earth orbits satellite. The effect of atmospheric drag is more pronounced. The drag has been affect the velocity of satellite. So it affect the velocity it causes the satellite not to reach the aperture height successfully resolution. So stationary keeping the equalized of Earth geostationary to drift slow along the orbit. So depend upon the stationary kit. So elasticity of Earth causing geostationary. So Earth causing geostationary satellite to drift small to 0.75 degree E and 105 W. To count the drift, oppositely directly velocity components impact the satellite by means of jet, which pulse once every 2 weeks. So here, so the Earth causing the geostationary satellite to drift some small along the orbit. So it distracts from the orbit. So this is the latitude and longitude. So we already discussed about geostationary and non-geostationary orbit. So geostationary orbit means nothing but, so the geostationary orbit is one which satellite orbits the Earth at exactly the same speed of Earth. So same speed of Earth means, so the satellite rotates and it is speed with the same speed with the Earth means nothing but that is geostationary. A satellite orbit in a geostationary orbit appears to having in the same spot in the sky and directed over a same path of ground at all the time. So next one is geosynchronization orbit. Once the satellite synchronized with the Earth's rotation, but the orbit tilted with respect to the plane of equalator. The person most wide credit with developing the component of geostationary orbit notes for science fiction. Other earlier point that the bodies travel a certain distance above the Earth on the equatorial plane would remain motionless with the Earth's surface. The geostationary object orbits are certain distance above the Earth, and any closer the orbit would decay, and further they would escape the Earth gravity together. Since the only geostationary orbit in the plane with equalator at 35,786 kilometers, there is only one circle around the world. Those conditions obtained. So next one is geostationary satellites. What are geostationary satellites? So there are two kinds of mankind satellite. One kind is orbit Earth once or twice a day, and another one is communication satellite or packed in stationary position 35,900 kilometers above the Earth, above the equalator of stationary Earth. The most pre-mentioned satellite is medium Earth orbit (MEO), or the satellite compass with global position system. So the global position system was developed by US military and then opened to the civilians use. It is today tracking plane, ship, train, car, or anything that moves. Everyone can buy a receiver and tracking their exact location using GSM receiver. So this is a satellite that is launched by a US military, and so they are launched for GPS. So in the mobile, Android mobile, so we are connecting GPS. So GPS is connected means it is connected with satellite. So when we are moving to other places, so it gives the latitude and longitude of the place where you are going. So we are given a destination, source and destination. So we can reach the destination without any failure with an optimized route. So this is the Google Map. Google Map. So in Android mobile they are using Google Map. So the Google Map we are connecting with a GPS. So that is a satellite. Those satellites are traveling around the earth at about 7,000 mph. 7,000 mph. GPS satellites are powered by solar energy. So GPS satellites are powered by solar energy. They have backup battery on board to keep running their solar power. Small rocket boost on each satellite, keeping there flying in a correct path. The satellite have a lifetime of 10 years. So after 10 years it is to be rehabilitated. But in Indian satellite there is no rehabilitation. Only we can launch the satellite. So it is used for, they are given a lifetime for 5 years, means after 5 years we cannot use. But in other countries, in NASA research, they are given a spacecraft. They are given a spacecraft. Recently 20 members are going on the spacecraft and repairing the satellite and stay 1 week in the satellite and repair and rehabilitate the satellite, and they come and reach the earth. And exactly 35,900 kilometers above the equator, the force of gravity is cancelled by centrifugal forces. The rotating universal, this is called ideal spot to park a stationary satellite. So this is the in top view. This is the earth. Okay, top of the earth is north and the bottom is south pole. So these are the south pole. So here we are located the satellite from the earth 22,300 miles. So in the same manner, so this is here, this one is the same manner we are launching the satellite. So we are having 3 stations. Okay, we are having 3 stations. One is downlink earth station, another one is uplink earth station. So downlink means the signals from satellite is communicated to the earth station. So uplink means nothing but the earth station is communicated with satellite. So this is the diagram. So non-geostationary orbit. For a non-geostationary case, the most important of those are the gravitational field of moons and suns and non-spherical shape on the earth. Okay, so we are discussing about non-geostationary orbit. Other significant force are solar radiation pressure, reaction of satellite to motor movement within the satellite. As a result, station kept must be carried out maintains the satellite without limited normal geoposition. In a general, geosynchronization does not have near the geostationary, and there are number of geosynchronization satellite that are in highly elliptical orbits. So highly elliptical orbits. The low inclination make it difficult to locate the position of ascending nodes, and smaller eccentric make it difficult to locate the position of preaching. So here, so there is some distraction. So we already know that ascending node, that the earth is sphere on. The bottom of earth is south and north. North is top. Another one is so we are calculating the because of low inclination, the angle W and alpha can assume same plane. The latitude of the subsatellite points are east earlier rotation. The Greenwich sidereal time give the eastward position of Greenwich meridian, relates the Orient's and his substation point is the longitudinal, and means longitudinal of satellite is given. So when this is the Greenwich meridian related line. So one we have studied about longitude of the subsatellite. Another one is latitude. So latitude is depend upon the Greenwich meridian relates. So depend upon the Greenwich meridian, we can measure the longitude of the